Hi, welcome to product review by watthour. In this review we are going to have a look at this XY-SEP4 Buck-Boost converter with power, energy, current and constant voltage, with input voltage of 5 to 30 volts and output voltage of 0.5 to 30 volts. This is 35 to 40 watt and output current of 3 ampere. How to charge your battery, either one cell or multiple. Charge this one. Wow, this is unbelievable. They did not put any silicone or heat transfer material or compound. You see, just smoked. Unbelievable. You can get the resources for this video by visiting our website, watthour.ca. I purchased it from AliExpress. This was the package, and on the package it shows the DC 5 volts to 30 volts and output shows 0.5 to 30 and 4 ampere 35 watt, whichever comes first, and the model is XY-SEP4. I bought it from this store for $8.80 plus $2.32 shipping, which you can receive it in 15 to 30 business days. And if I search, you will see that tons of other stores are selling it. I have no affiliation with this. We have 4 push buttons here at the top. This is up and down, and then we have a setting and power. Now currently the output is on. We can press it and turn it off. So this has tons of features. You can set a constant voltage and constant current. You can set the voltage using this potentiometer, very solid build, and we can set the maximum current. It has a heatsink. All the terminals, everything looks very nice quality, and this can be inserted in a panel as well if you have a panel. And here are the terminals. You can connect your VN, the positive and negative, in here, and output the negative or side by side, so you don't make mistake. The positive on that side and the positive for the output is on this side. And because you can go up to 4 ampere, make sure to use a thick wire so you have very little voltage drop. So here are the main features of this. This has a reverse protection polarity. If you connect it in reverse, it will be protected. Over voltage protection, by mistake you increase the voltage, it will be protected. Over current protection, it prevents it, so it kicks in. Over power protection, over temperature protection, when the temperature reaches 100 degrees Celsius, it will shut off. Energy and capacity, over energy and over power protection. Play voltage precision is 1%, and the resolution is 10 millivolts, 0.01 volt you can set, and the display current is 1.5%. keep that in mind. And you can set up to 1 milliampere, and the efficiency is 88%. The switching frequency that it does a conversion is 180 kilohertz. The output on, so it will be on, and you can turn it off from the switch. And here to open this module, it's very simple. Just pull it, and it has been prepared in 2 layers. This is where the display is and the driver, and this is the power section. And I'm going to show you these components. This is a microcontroller that is doing everything, all the controls that you see on the screen. This is the display driver that is driving this display, which I'm going to open it, and this is the control module, the power module. And if I open it from here, the heatsink, wow, this is unbelievable. They did not put any silicone or heat transfer material or compound. How could this get all the temperature with simple connection, because this cannot be flat. This is bad design. So as soon as you receive it, put heat transfer compound or fiber that is transferring the heat. Current is passing through this, and it's detecting the current from here, and based on that measuring the voltage and power and everything. For the Buck-Boost converter chip, this is new Voton NE76003AT. That's a microcontroller that is taking care of everything that is happening in this module. New Voton N76E003. The next chip here, this is a display driver, and this is the RAM mapping 32x4 LCD controller. HT1621 is a 32x4 RAM mapping for LCD from Holtec. As you can see, this is just a diode, 2 diodes, rectifier. That's a main rectifier for boost converter. SD1020 to SD10100. These are different versions of the same Schottky diode, and the one that is used is SD1040. 50N06 is the main MOSFET that is used in this module. That's N-channel MOSFET. Leading voltage, drain source voltage is 60 volts, and the continuous current and 10 volts is 50 ampere. This one is a Schottky diode, and this is the FP5139. FP5139, this is a synchronous boost converter. That's the main converter that is boosting up the voltage for us. LM358 is a low power dual operational amplifier from ST Semiconductor. So this portion now, so this is an LCD. Now let me show you the functionality of the device. The power is connected, input and output, and this shows off. When I press the power, it shows on, and this is the output voltage at the moment. And to change it, to see the input, we press this push button and it shows N. When you see N, that is the input voltage, and when I press it again, it shows the output. Currently it shows the current here. The upper section will be changed with this, and the lower section with this push button. If I press it again, it shows the power, and it shows energy, ampere hour or capacity, and this is the energy watt hour. So the previous one was the capacity, and it will just rotate, and this shows amount of time that it was on. For all these values, you can set limit. For current, for example, for this current, you can set limit and it will prevent it, or it will be constant current over current protection. And this is a power, you can have over power protection, and this is a capacity over capacity protection. Let's say you want to drain something like 3 ampere hour, and after that it will shut it off. And this is the energy watt hour, so you can also set that. And this is the time, also you can set the time, so this device can work, let's say, for 2 hours 30 minutes, and after that it will shut down if the time reaches. So with this we can just rotate. To change any of the value, if you press this once, nothing happens, but if you press and hold it, you will see a series of options for over. To show you what is the maximum voltage and minimum voltage that you can get from this. And if I press this, you will see that the input cannot be up below 4.7 volts, so I'm setting it at the same input, just checking the output. Now the current is around 2 ampere, here to show you. Now the current is about 2 amperes. Let me increase the voltage by rotating this potentiometer, the first one. Now the power has been increased. If I go here, you see 40 watt, so we cannot go with that. So let me increase the voltage. Over voltage protection kicked in, 31 volt. So 31 is set for over voltage protection. And now let's go with the lowest voltage that we can get with this. By the way, this is now heating up. And as you can see, the hottest spot is beside this heatsink around this capacitor, this area, and this winding, that's 60 degrees Celsius. So this is the hottest spot. And let's see the minimum voltage. I'm just rotating it counterclockwise. The output voltage can go as low as 0.47 volts. We're getting 0.5 volts up to 30 volts. And now when I press this, setting the gear button and hold it for about 6 seconds, this is the lower voltage protection or under voltage protection. So read this as V, I suppose, and P is protection. And then when the voltage goes below this value, it will shut off. So currently it is set to 4.7, and let's increase it. And I've set this to 6.5 volts. To exit, press and hold it. And to check the input voltage, I'm pressing this. Now it shows 9 volt, 9.95. Let me reduce it so you will see that when the voltage is reduced, the under voltage protection will kick in. So that is 7. So 6.5. You see, it kicked in, and now the output is off. So you will not get any current at the output. And if I hold this again and go to the next option and press it again, this is the over voltage protection. If you set the output voltage above 31, for example, and if you try to set it higher, it will turn it off. Let me show you. And now I've set it to 25 volts. Let's hold it for a few seconds. Now this is the input. Output is currently 0. Let me turn it on. Output is 10 volts. Let me change it. So as soon as I go above 25, you will see. So I'm rotating this clockwise. So 13, 15 now. and 19, so 20. Pay attention. 22, 24. So now I'm going slowly to 25, and output voltage protection kicked in. The maximum that you set for this device is 31 volts. The next option, if I hold it, and this is the overcurrent protection. Currently is set 4.1 ampere, and you can set any current. Let's set it to 2 amp. And save, hold it to exit, and 1.45 ampere. So the output is this current. Now if the output current increases, the overcurrent protection will kick in. Now I'm increasing it. Pay attention. 1.5, 1.6, 1.7, 1.8, and now I'm 1.9. So overcurrent protection turned the output off. And the next option, if I press it and hold it, one. This is over power protection. When the output power is above 35 or whatever set value you have, it will protect it. Let's set it for a smaller value. So I've set it to 18.6. Exit, getting about 1 ampere. Now this is in terms of power. I have to see the power. Now it's 13.9. It's around 18 point something. So I'm increasing my load. Here I have this load here. This current now shows here. So the watt in terms of power. So let me increase it. So 15 watts, 16 point something, and I'm increasing it. You can see the power here, or the current. I'm increasing the current to see the power. 18. So we are very close. 18.5. As soon as I turn it on, and over power protection kicked in. We can set it for overcapacity protection, and we can set the capacity of a battery or energy that you're consuming. And this is the energy, watt hour, and this is in terms of time. You can set the time so it can be turned off as soon as it reaches to that amount of hours or minute. To change it, if I press this again, it goes to the minute, so you can set it. This is the data group. It can remember 2 groups of data in terms of energy and power. This is 0, and also you can set 1. If you press it again, it will be 0. So you can track 2 energy sources with this, 0 and 1. And the default is always 0. Put a wire or create short circuit between these 2 terminals. As you can see, I put a wire between them, so this is now short circuited and this is off. At this stage, rotate this counterclockwise with both 0, and then rotate this clockwise. As you can see, it shows now the current. Now the current is set 59 milliampere. So let's set it for 1 ampere. As soon as I rotate, you see it is increasing. I'm going to set it to 1.5 ampere. So I set it to 1.5 ampere, turn it off, disconnect now this wire. And now I'm turning the output on. Now the output is about 1 ampere, so it is okay. Then I'm increasing the output current so you can see it. So you can see now, as soon as it reaches, it will control the output voltage, because now the output is 13.6. As soon as it reaches to that threshold, you see constant current appeared, and it tries to bring the voltage down to keep it. If I increase the output current more, so now the output voltage has been reduced and the current is kept at 1.5 ampere. So the same way you can set the current for the battery that you're charging. To set the maximum current, make sure to rotate this clockwise until you go to the maximum. I'm just rotating it about 20 turns. And when you rotate it clockwise, you can hear a click. Now let me show you. You see? You can hear the clicks. And that is the maximum current. Now, if I turn this on, I can increase the current. Let's see what is the maximum now. With 13 volts. Either voltage or power protection will kick in, because so 13 volts 3 ampere over power protection, because the power is limiting it. Now I'm going to do a series of tests. Input output voltage is 12 volts, as you can see it in here. Let me show you the input. Input is 5 volts. And now this, when you enter 5 volts and get 12 volts, this is called boost converter, because it's, let me turn it on. Let me do some series of tests. We will see the input voltage, input current, even though the voltage is shown, but the current is not shown. So we will see the input current to this, and from here we will see the load. This is the load current, and this is the load voltage. Now this is off. I'm turning it on. Now this is on. We will see the output voltage here, but the load is not connected, not turned on. So I'm turning it on. It is set here to 1 ampere. And now we have 1 ampere, and this is the input current with 30 volts 0.92. So this is 27.6 watts at the input, and here we are reading at output 24 watts. It's 1 ampere, 24 volts, so that's the product. From 30 volts, this is now stepped down, and we are getting 24 volts. Let me go for 2 ampere. So over power protection, because if we set this to 2, so 2 times 24 is 48, so this cannot handle 48, and I'm turning it off. So when this happens over current, over power protection, just press the power and it will turn on. Now it's off. So we go back. I'm turning the current to 1 ampere. Now it is on. Now I'm going 1.5 ampere. So 1.1. As you can see, we are getting 26 watts. We could also switch in here to see the watt here, the power. So that's good, we can see it. And let's go 1.2. So now this is changed to 1.2. Now we are 28, 31. So I'm increasing the current, and you can see it here. And at each stage you can see the input current and input power. Now to get the efficiency, we can get the output power divided by this input, and that's our efficiency at that voltage and current. Now it's 1.4, so 33 watts, as you can see, 33, and input is 37.8. Over power protection kicked in. So let's go 1.4, turn this off and turn it on. So what we learn is that if you want to get 24 volts out, you cannot go more than 1.4 ampere. So that is your maximum. I've set the output to 12 volts. Here you're reading it. Still the input is 30 volts. Let's turn on the power. We got 1.4 ampere. Here we're reading it, and that's the input power. The input current is here 0.66 ampere and 19.8 watt at the input, and here is the output. Let's go 1.45. I'm increasing it. 1.6. Pay attention to this power and the current here. 1.7. 21. 1.8. This voltage is slowly dropping, but so 24 watts. Now 2 ampere, so this is 25 watts. As you can see, the voltage has dropped because the constant current is now kicked in, constant voltage and current, and I have to increase the current. I'm increasing the current from here. Now let's increase it more. (2.3) 27 watts, 2.4 28 watts, and here is the input 32, 1.09 ampere at the input, and that's what we are getting at the output. 2.5, that's now 30 watts, 31 watt. We are getting almost at the edge. Let's see. Now the output is 31 watt, input is 35.4 watts, and this is input current. Now it's 32 watt, 2.7 ampere we can get at 12 volts. I'm sure if I increase it, it will go above 35 and this will kick in, but let's do it. So 28, 2.8 ampere. So you have to be careful here. Output is not important. This is now important for us. You see, now over power protection kicked in. I have to reduce it, turn it off, turn it on again, and we can get 2.8 ampere at 12 volts with this. Now I have set the output voltage to 5 volts, input is 30 volts, and let's turn on with 2.8 ampere, 17 watts as you can see is at the input and 13.4 watts at the output. The voltage has dropped to 4.8. Let me rotate the current knob so we can increase the current. Now you can see this shows 4.8 volts while here is 4.9. I trust this is more accurate, so this is now not accurate. Let's increase it 2.9, 3 ampere. Now we are getting 3 ampere and the voltage is almost 5 volts. 3.1, 3.2. Remember, this cannot handle above 4 ampere, so whichever comes first it will turn off. So 3.3, 3.4 and 5 now. Now overcurrent protection should kick in. 3.6. So input is now 22.5 watts, the output is 17.6. The voltage has dropped 0.3 volts. Here it shows 4.9. .8, 3.9. So we are getting 4 ampere. The device is very cool, nice. So it turned off because we went above 4 ampere. Now input is 30 volts, output is 3.3 volts. It is already at 4 ampere. Let me turn it on. So the voltage has already dropped half volt, 0.3, 300 millivolts. So that's not right. Let me increase the current in case the current is kicking in. This voltage is not accurate. This is correct. So the output voltage also at the lower values is not accurate, especially when you have 4 ampere. Let me turn it off. And now the voltage has increased significantly at back to 3.3. So let's reduce it. Now I put 3 ampere. At 3 we are getting a little better, but still at 3.3 volts with 3 ampere. This is not right. Let's reduce it 2. So we are getting 3.2, and here it shows 3.3. And now I have changed the input voltage to industrial standard of 24 volts, and now the output is 12 volts. You can read it here. Now 2 ampere. Let me turn it on. So this is 2 ampere now. The output is 23.8 watts, and the input is 27 watt, 26.9, and here is a current, the input current here. So this shows the input current, voltage, and power. So let me increase it to 2.5. Now it's 25 watt. Increasing it, 26. more. I'll go to 35. Let's see, by increasing this current. Now over, that's correct, the power. Now over power protection kicked in. So we are getting 2.8 ampere. And now input voltage is 24, the output is 5 volts. Let's go 2.8 ampere. So we are reading the voltage dropped a little, almost 150 millivolts, but the input is 0.7 ampere, 17.1 watt, and this is 13.6. Let me increase it to, now this is 3 ampere the output, and let me increase it to 3.1. Remember, 4 ampere is the maximum, so at 3.3, 3.4, I'm increasing it slowly. 3.5, the voltage is dropping slowly. So the voltage drop more when it reaches 3.7 amp. Three 3.8, 3.9, 4 is the maximum. Let's see, now it shows 20 watts, and here we are reading, because this reads the current incorrectly, so let me switch it. It shows 4.028 ampere, while it is just 4 ampere. 28 milliampere, that's not that much, so still very good. So 19 watt is the output and 24 is the input. 1 ampere is the input here. 1 times 24 is 24, but the output is 4.78 and 4 ampere. And we cannot go above 4 because the protection will kick in. Now the input is 24, the output is 3.3 volts. Now the input is 24, the output is 3.3 volts. It's set at 4 ampere. Let's just turn it on and see. So 4 ampere is the maximum, and this is the input, 17.3 watts. The output is 12.23. So and now input is 12 volts, output is set to 5 volts here, and we are reading 5 volts. I've set it to 1 ampere. Let me turn it on. So now the load is drawing 1 ampere. As you can see, it shows 0.994, and the power is 5 watt. 5 times 1 is 5 watts. Input is 6.2 watts and 0.5 ampere at the input. And I'm going to increase it to 2 watts. 2 ampere. Now as you can see, it's 12 watt and 9.88. The output voltage has dropped a little. Now it's 2 ampere, still acceptable. Let me go 3 ampere. Now we are at 3 ampere. Now let me change it to 4 ampere. Now the output is 4 ampere, but the voltage has dropped. Now we are getting 4 ampere at 5 volts. And input is, as you can see, 24 watts, 2 ampere. Now input is 12 volts, output is 3.3 volts here. So let me reduce the current by 1 ampere, so it's now 3. Still, this is big difference. We expect better voltage. So 2 ampere, we can get 2 ampere at 3.3 volts. Here the input is now 5 volts and the output I've set it to 3.3 volts. You see it here. Let me go with 2 ampere. Now the load is taking Now the load is taking 2 ampere here. We are seeing 3.3 volts and the input is 1.76 ampere here. Let me increase the current to 3 ampere. Now the output is 3 ampere, but the voltage has dropped, and also the input current you can see is 2.8 ampere. So this voltage is not acceptable because it's now more than 150 millivolts. That's not acceptable with this small value, so we have to go with, so even here we have about 90 millivolts, but if you can accept that, then 2 ampere it can give you, then it can give you 2 ampere. And now let me show you how to charge your battery, either one cell or multiple cells. And this is the data sheet for XY-SEP4. This is used in so many chargers. And here, so we will be using 4.2 volts. That's the maximum. So when the battery is fully charged, we go up to 4.2. The amount of current that you're charging depends on what is the capacity. And this is a data sheet for my battery, NCR18650B. The capacity is 3200 milliampere hour. To know that one, if this is 3200, you can charge it at 3200 milliampere, or you can charge it lower. The smaller the amount of current that you charge, the longer the life of the battery, because if you charge it with higher current, the battery life will be decreased significantly. You can do, let's say, half of the capacity, that's 3200, we can go 1600. So 1.6 ampere we can charge this one, and we can do it either single cell. If it is single cell, we set it at 4.2, and if we have 3, then 4.2 times 3. If you are charging 3, that will be 4.2 times 3, 12.6. So we will set now for this one 12.6, the output voltage. You saw the smoke? As I was changing this, the smoke was coming. So I set now the voltage to 12.6, Now we have to set the amount of current. The current to 1.6. This is the output, and to set the current we have to create a short circuit and then set the current to the 1.6. You see it says over current protection. Don't worry. Create short circuit and then turn this to the left as much as you can, like 10 turns. So I did that, and now let's turn it on, and it shows 1.4 because I put it, and it is now short circuit the output. So we can go 1.6, and if I rotate this clockwise, pay attention, it goes to 1.6. So now it is 1.6 and then disconnected. If you disconnect it, now the voltage is 12.6, and now I can connect this to my battery. Here is the positive, because it is 3-cell, and the negative is on this side. Now as soon as I connect it, you can see, because this is a little full, the current is now 1.2. So now what happens is this voltage will increase slowly. As this increases, this current will decrease. When it reaches at 12.6, the current will stop, and your battery is fully charged. You can see already the current is being reduced slowly, and the voltage is increasing because this battery was almost charged. Once the charge is completed, the current will be 0. And here, if you want to know the input is 17 volts, so you can connect any voltage, and the current is 0.92. The power is 15.2. Once the voltage reaches 12.6, then increase it to 2 ampere. You see it shut off immediately, and it's very hot. Let me turn it on. OEP, and I smell. This means over energy protection. Now let's charge this one cell, and because the voltage is 4.2 maximum for this from the data sheet, we set this to 4.2. You see, just smoked. Unbelievable. I didn't do anything. Here. So it created short circuit, and the current was about 13 ampere. I removed this from this module and a broken one from this module. I'm going to put this one back in here. Now I've replaced the potentiometer from the other module. Thank you for watching a video from Watt Hour. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos. In this video, we are going to do the review of this XY-SEP4 Buck converter or step-down converter with a maximum current of 5 ampere. I'm going to test it with the minimum and maximum voltage and also a different current and different voltages. I will continuously going to show you the